this is y plus 2x is equal to 0. This is y plus 2x is equal to 4. So the region is right here, which is a pretty regular region if you look at it, right? But if I ask you whether it is x simple region or y simple region,
You can choose.
you can choose both of them. But unfortunately, describe it into a y simple region is not that straightforward. Because if it is y simple region, I need two numbers for x. Two numbers for x are pretty clear. I need to find intersection here, intersection here. But the lower function is not a very nice function here. The lower function has two pieces. The other function has two pieces as well. So this is indeed a y simple region, but in order to describe it, it's pretty ugly. You have to have a piecewise function on the lower part and piecewise function for the upper part. So this is still a y simple region. It is still an x simple region as well, but the left and the right functions are both piecewise functions. But I can do a simple change of variables to make this integral much nicer. And I see y minus x twice. I need a u is equal to y minus x. And v is going to be y plus 2x. So in this case, I will be simply rewriting this double integral with respect to u and v. So u goes from 1 to 4. V goes from 0 to 4. And then I need to change everything inside. So this is going to be u over v plus 1 to 4. Okay? So in the very beginning, it is indeed a y simple region, but it is pretty hard to compute. After I do a change of variable by introducing u and v here, I can easily identify this region as a cube. Or in this case, it's just a rectangular region. All right? And then I'm taking d v in the inside, so it's 0 to 4, and du in the outside. But I do have to include Jacobian factor partial xy to partial uv. Okay? So one extra work you have to do. If I'm computing this Jacobian, I have to write x is equal to a function of uv. All right, in order to take the derivative. But unfortunately, these two are not. All right, these two are u is equal to whatever of xy, v is equal to whatever of xy. So I cannot take this part of the derivative directly. So what do we have to do? You have to solve for x and y in order to compute the Jacobian. So here, x is equal to y is equal to x is equal to, if I divide this, v minus u. So I think I have computing that already. So v is equal to 2u plus v divided by 3. So you have to solve for x, y, and then take the partial derivative with respect to these two functions. And then getting a Jacobian, take the derivative, take the absolute value, you can compute this double integral instead. So I also did the computation here. My computation shows it is equal to 42,284 divided by 1,875. Okay, that's the final answer. I want to mention this problem in the following sense. First of all, beyond this step is really the key testing part of chapter 3. I want you to be able to use change of variables. As long as you have done that, all the following works are single variable calculus. So to me, I don't like these kind of problems. In order to get the final answer, you have to compute the super large numbers, and they will not give you any credit if you miss by 1 or 2. So I don't like these kind of problems. So this is my recommendation. If I mentioned this before, so if you have done all the computation on your notebook with all the required steps, but you couldn't come up with this number in order to fit in the computer to make you get the credit, you can bring your notebook to me. I can reimburse any point as you want. Okay? That was me, so you don't have to spend too much time to worry about whether I'm going to end up with this crazy number. Okay? That's the first thing I want to mention. Second thing is, in the test, in the final, you're not going to see this kind of numbers. Okay?